Hi everyone, and welcome to Algebra 2, Chapter 7, Lesson 1, Exponential Functions, Growth, and Decay. In this lesson, we're going to talk about what an exponential function is, how to tell if it's modeling a growth or a decay in a variable, and how to graph them. So let's take a look at some terms first. An exponential function is a function with the variable in the exponent. So that means in the function, you have a number as the base, and then the exponent is going to be an x. So that's an exponential function. An asymptote shows up in the graph of an exponential function. It's a line that the graph approaches but never touches. So notice in my picture here, the blue line represents the curve of the function, and this red line is the asymptote. It's the line that it approaches, but that curve is never going to pass through that line, and it's never actually going to touch it. It's just going to get really, really close. Exponential growth and exponential decay describe whether the function is increasing as you go further to the right, that would be growth, or decreasing as you go further to the right, that would be decay. So it's just describing whether the function is an increasing function or a decreasing function. Okay, so we have an exponential function with the variable in the exponent. We have the asymptote, which shows up on the graph. It's a line that it approaches but never touches. Exponential growth is when the function is increasing as you go further to the right. Exponential decay is when the function is decreasing when you go further to the right. So let's take a look at how to graph some of these functions and how to tell if they're growth or decay functions. In example 1, it asks us to tell whether the function shows growth or decay, and then they want us to graph the function. So to tell if a function is growth or decay, you find the number that's raised to the power. If that number is more than 1, it's going to be growth. If that number is less than 1 but more than 0, so we're talking about a decimal number like 0.5 or 0.6, something like that, then it's going to be decay. A negative sign in front is a reflection. Remember, that's a type of transformation. So you have to just be a little careful about that, really think about what's going on. So anything between 0 and 1 in this position right here would be decay. Anything more than 1 is growth. So this particular function is a growth function because 1.5x is more than 1. Now to graph the function, what we need to do is just create a table of values. You pick x values, you put them into this function, and you'll get y values. So what I did is I picked some x values and I did the calculations myself, and this is what I got. So 1.5 to the negative 2 power is 0.4. 1.5 to the negative 1 power is 0.7. 1.5 to the 0 power is 1. And you'll find that often these graphs do go through the 0.01 because anything to the 0 power is 1. And then I just did 1.5 to the first, 1.5 to the second, to the third, and to the fourth. Now you'll notice that we do get graphs that go very high because these are exponential functions. Thankfully, this is a relatively small number here, but if it was a 2, once you got to the 4th power, you'd be up at 16. So you might need to change how you count on your y-axis to make sure you can fit in these points. But let's see how this graph looks. Okay, so I graphed the points, these red dots right here. Those are my points. I connected them with a curve. Notice this is increasing as you go to the right. It's going up on this side. Also notice that this graph is approaching 0, but it's never going to touch it. So this x-axis is our horizontal asymptote because the graph is approaching it, but it's never touching it. There isn't a power that I can put 1.5 to that it would actually equal 0. So it's never going to touch the x-axis. Let's take a look at another graph. Okay, so again, we have the same directions. It says tell whether the function shows growth or decay, and then graph. Now look at how they've written this function. It's 30 times 0.8 to the x power. Notice the x power is on the 0.8, not the 30. So this is a decay function because 0.8 is less than 1. Okay, and now I'm going to get the x values and I'll show you what that graph looks like. Okay, so notice the points that I used. I used -1, 0, 1, 2, 3, and 4. And all I did was I put them into this function and I got these y values. Notice at 0, I didn't get 1. Now think about why that would happen. If I put 0 here, I would get 0.8 to the 0 power is 1, but I had 30 times 1. That's why it's 30. That's why I'm not going through the 0.01 for this particular graph. Now also notice that when I graphed it, I counted differently on my y-axis. I counted by 5s here. You do have to label when you do that so somebody looking at your graph would know what you counted by. And another side note is that you don't have to count the same on your x-axis. Mine does in this case, but you don't have to. Just make sure to label it. So like if you wanted to count by 1s on your x-axis, that would be perfectly okay. Also notice that because this is a decay function, it's going downward as you go further to the right. And that x-axis is still the horizontal asymptote because it's approaching it but never crossing it. Okay, so that's it for this video. Make sure you watch the other video for this lesson where we're going to talk about how to write a growth or a decay function based on information.